So this video is gonna cover what to do in certain scenarios when you're dealing with BRAT and drainage areas, when you have a situation like this, which is what watershed we're in right now is the lower Yakima watershed, and the Yakima River comes in. I've got symbology right now just pertaining to drainage area, and red and darker colors are higher drainage areas, as you can see over here, and the lower drainage areas are the green. So you can see all the headwaters are right here in lower drainage areas, and then we've got our main stem of the Yakima River going up through here, and it continues on. So as you're running BRAT or any other tool on this section, but specifically BRAT, and dealing with flow accumulation rasters in drainage areas, you're not taking into account the topography up here of other watersheds that aren't your focus area, right? So this is like this is your Huckate for the lower Yakima that we're working with. And you're not taking into account this Huckate up here, nor its drainage area. So as you go through the tool, it's only basing information off of the current drainage area that you're working in. And you can see that, this is the inflow to the flow goes from, the top of the screen to the bottom of the screen. And so the drainage area, and this is one that I fixed already, but you can see right here. So we've got a drainage area of 8,381 kilometers squared. BRAT will just put it out as, based on the flow accumulation raster, which will be something, this is 25, which is just a braid handler thing, but originally it will count it as just like 0.01 for the total drainage area for it. So the way that I've gotten around this, and the way that you should approach this is, all right, it has a higher drainage area going into it than 0.01 because it has the drainage area above it, and it's a pretty big river. It's inflowing in, and the only sections that you really have to be concerned about this is usually like the largest river that's going through your watershed. In some cases, it might be the Snake River, the Columbia River, Bear River, something like that. And so what I do is I go into stream stats and just go into here, go into the link, and you can see that there is, hopefully this one will show it. This one doesn't. Click on the one right above it. I gotta find the specific one. It's like one of these that I did. It will come up with a drainage area. Okay, so right here. Okay, this is a little further down, so it's higher than that 8,000. Or a little further up, so it's higher than that 8,000. But what you do is you can. Oh no, it might be. It might be because ours is in kilometers squared. So you'll just take this number in square miles, convert it to kilometers squared, and that should be the number that you'll want to remember for it. But the key is to basically, take the closest, if I'm looking at the Yakima River here, and the top of the watershed hypothetically is right here. And as you can see, this goes off on this little trib right here, but maybe something right here is that you say, all right, my watershed ends here, but I have a stream gauge up further. I want to grab the drainage area from that stream gauge because it will account for, all this stuff that is happening upstream and what the true attributes of that stream gauge would be, or that stream would be for drainage area. And what I do is I go into here, and let's just say, all right, I'm going to open the attribute table, go to the selected stream. Okay, and I think what I've got is selection, make this a selectable layer. Okay, so I can select it now. And you can see right here, all right, the drainage area, this is one that I've already fixed. So the number that I added is probably this 8381, which is square meter to square kilometer. Let's just see really quick. So we've got, square mile. Three 81, which is about 3,235 kilometers squared. So I must have picked a different stream gauge in a different location than that one. But that was the number that I looked at on there, and I'll just pick all of these main stem value, or the main stem for the Yakima. And you can do this in various ways. You can go through like I'm doing right now and just like select them all. And obviously this is a little bit easier for me now that I've already done all the editing. But you can see it can be kind of time consuming, right? And obviously I missed a little piece right there. And so it can be time consuming, right? The other thing that you can do is you can look up in your stream in the flow line, and you can actually see, what's the named river and use that as a guide and then go in. But what I'm doing is I'm basically selecting all those. Once I have all those selected, I go to my drainage area right here, and I'll do a field calculator. Okay, I'll just say yes. And what I'll do is I'll do my drainage area, because the important part is you want the new drainage area right here to equal the old drainage area that the flow accumulation and the BRAT tool, that the BRAT tool calculated from the flow accumulation raster, and you want to add the new or the additional watershed value above. Okay, so I would just add this 8381 to the existing drainage area that was calculated by BRAT. I'll just press OK, and it should equal something new for this value. And you can fit, and the whole purpose of this is basically, you get a more accurate drainage area value, but you also, later on in the tool, it's helpful when you're calculating that threshold value, because if you don't do this, your threshold value will only, it will only go up like about this far, and then you'll start going further up into the watershed because, you don't have a larger value for this drainage area, but it can't support beaver because the river's too wide and it's too powerful. So it would just blow them out. So that's the key to this is adding on other drainage area values. So to make your network more real for drainage area and fixing your threshold. So yeah, that's editing your drainage area, just considering a section of river that has a larger river going through your watershed and out the other side, so, and not just being all inclusive in your watershed.